I want to move into some experiments that you could do using a magnetic field. Let's see if I have more blackboard space. Oh, I do. Alrighty. So one thing we can do using magnetic fields is select for particles of a particular velocity. Specifically, let me draw the setup first, and then I'll explain. So the setup is, say we have an ion emitter that emits, in this case, particles that have a single electron positive charge, and then we put it through a B field that's pointing out of the board. On top of that, we put an electric field that's going up. What good does that do? Alright, let's take a look at what's happening here. So, these are positively charged ions. Under the E field, they want to move up. What about under the B field? Under the B field, they go right hand, particles are going in this direction. So if you curl your hand out, the thumb pointing down. So under the B field, the particles want to move down. So I can answer your question. If I put a slit at the right end, which particles go through the split? In other words, which particles will go through this region of both E and B fields completely undeflected? In other words, moving in a straight line. Well, we know that one force is pointing up, the E force is pointing up, the B force is pointing down. Let's equate the two. Do you see what I did? Is everyone okay with this? Okay, so if I plot this out, I find that the particles that make it through this hole at the right end are completely straight with location. So I guess in this case, let's call this the y coordinate. That's the same as the y coordinate in which the particles entered. Has to have this velocity here. So I can actually tune the E and B fields to get particles of a particular velocity. So we call this setup here a velocity selector. Okay? And actually, we can use this in many different ways because we now know that the particles exiting this hole here have this velocity, which we can change by manipulating either the E or B field. So now we can build something called a mass spec, or a mass spectrometer. Have you guys heard of that before? A mass spec selects ions that have, a mass spec determines the mass of ions. So let's say all ions here have the same charge, that is plus 1e. And let's say we line, sorry, I ran through some recording issues there. So if we put a B field here, and if we line this end with a photosensitive plate, when the ions pass through here, they're going to make a semicircular trajectory and hit this plate at a particular point and make a dot on the film. If we develop the film, we can find out where the dot is and then measure the radius of the trajectory. If we do that, then we know the radius of the trajectory, and we also know the velocity of the particle here, because we set the velocity with are E and B fields. So then, going back to the equation we saw before, we can determine the mass. So, one thing to note about these equations is that I don't want you guys to remember them, but I want you to rederive them from first principles every time. And the reason I ask you to do that is because, number one, it enhances your memory and understanding of the material, and number two, it's just, it's pretty straightforward to do so. And I think it's good practice, in the event that they should change, a tiny variable or something, you won't get confused. And especially with physics, there's so many different variables that, you might get confused yourself.